This time we're going to discuss the repetition or looping structure, which is equivalent to the while statement in programming. This structure provides for the repetitive execution of an operation or set of operations or routine while the condition is true. The first thing is that the condition is evaluated before executing any process statement. And as long as the condition is true, the process is executed. Otherwise, control flows out of the structure. Try to look at this diagram. Notice that in this structure, we are using the diamond symbol, which is the decision symbol. And what we have here is a condition. The input flow line goes into this question, and then as we have discussed last time, it has two output flow lines, the true and the false, or the yes and the no. So when the condition is true, it goes to execute the action or the set of actions, and it goes back to check the condition. When the condition is true again, it goes to execute the set of actions and it goes back to the condition. So that is how it goes. And as long as the condition is true, the action or the set of actions are executed. And when the condition becomes false, the control flows out of the structure. Let's try now to construct a flowchart to display the integers from 1 to 10 and compute the sum of these integers 1 to 10. We start with a terminal symbol with this label, and then we initialize two variables, x set to 1 and sum set to 0. After which we proceed to this part, the condition, and our condition goes to say x is less than or equal to 10. Now remember that our intention is for variable x to proceed from 1, the initial value, then to 2, and then to 3, and so on until we reach the value 10. So this is the range of integers from 1 to 10. These are the values of x. So one value at a time. For each execution of the loop body, our x has a unique value. So from 1 to 2 and 3 up to 10. So this is a question mark here because we're asking the question or we are testing if x is less than or equal to 10. So when the value of x reach to 11, then that makes the condition false. So the two output flow lines, which are the true and the false, we could have the true here, say if this is true, and then since we have no more space, we will use an on-page connector with the label A, and then we proceed on this part. So this is the exit point of the on-page connector A, and this is the entry point of the on-page connector A. So again, when the condition is true, what are the actions we're going to take? First, we display X. So since it is display, its output, we say here, display X. After we display X, we proceed to compute the running sum, which is simply sum gets sum plus X. After we compute for sum, then we increment the value of X or we increase the value of X by 1. So we would say X gets X plus 1. So from the initial value of X equal to 1, after we have displayed X, which is 1, and compute for the running sum, then we increment it. This time X becomes 2. After that, we go back to the condition. Okay, so we go back to the condition. So we could use here an on-page connector labeled B. So this is our second on-page connector. And then we proceed to this part here. So the exit point is this one for on-page connector B, and this is the entry point. it goes back to the condition. And how about if the condition is false? Okay, we could put it here, the output flow line. And we could use another on-page connector, say C. So this is the exit point of on-page connector C. And the entry point, let's write it here. So again, when the condition is false, we would like to display the value of sum, and then we terminate the flowchart. Okay, so we could say here display sum. After that, we have the terminal symbol N. Let's try to check if this flowchart is working. So according to our problem, we are going to display the integers from 1 to 10, and so we make use of a variable x, which is initialized to 1, and then we increment it every loop iteration until it would reach the value 10, the upper limit of the range, which in this case the condition is still true. And the next time we increment x, when it becomes 11, this is the time when the condition is false, and we exit from the loop structure and display the final sum and end the flowchart. X is initially 1 from this initialization, and sum is 0. And we check the condition, x is 1 less than or equal to 10, that's true. So we proceed to this, display x. So say this part here is the output. Our first output is 1, display x, x is 1. And then compute for sum, sum is 0 plus x is 1, so sum becomes 1. And increment x, x here becomes 2. And then we proceed to, we go back to the condition. This time our x is 2 less than or equal to 10. That's true. And so we go here in the loop body, display x. Our x now is 2, so we have an output 2. Compute the sum. Sum previously is 1 plus x this time is 2. So sum becomes 3. Okay, that's the sum of 1 and 2. Then we increment x, x becomes 3. And then we go back to the condition, 3 less than or equal to 10, that's true. So we go back to the loop body, display x, which is 3, and then compute the sum. So this is now 3 plus the new value of x, which is 3. The new value of sum is 6. And then we increment x, x becomes 4. And goes back to the condition 4 less than or equal to 10, that's true, and we go back. So that's how the loop works until we reach the value of 10. And so the output here would be 1, 2, 3 up to 10. When x is now 10, and we have displayed x, which is this one, and the sum now would be the sum of 1, 2, 3 up to 10. By this time, when we have computed the sum of 1 to 10, when we increment x, x becomes 11. And when we go back to the condition, we check it, x is 11, this would now be 11 less than or equal to 10, which makes the condition false. And so we proceed to the connector C and display sum, and the flowchart ends. So our flowchart is a functional working flowchart.